Okay, let's get it.
So, it's all JavaScript. Let's start. Yes, it's all JavaScript. Wanted to do black, white, I didn't know. This one I could add NG on it, our new mascot. You might have seen this in the last release. So it's all JavaScript. I will talk about JavaScript today, but also I will talk about JavaScript, and of course, JavaScript. And there's one thing I want you to understand is JavaScript is awesome. It's the best thing ever, I love it, and I hate it also. It was invented by that dude, Brendan Eich, in 1995, and it took him like 10 days to write that language for Netscape, so to have some kind of dynamic things to a static language, which was HTML. So in 10 days, he wrote the language, JavaScript. It was already awesome from the start. And I don't know if you remember what happened in 95. Something like this. Yes, same day as same year as the release, as the best operating system ever, and that gave us that celebration. You might recognize Steve Ballmer, Bill Gates dancing on the Rolling Stones just to start an operating system. Back then, Windows was very cool. But please, let's go back to JavaScript. JavaScript is awesome. Do you know what happens if you do type of none in your JavaScript console? Object. Do you have an idea? No, it's not object. Number. It's number. So type of not a number is actually number. JavaScript's awesome. So what happens in the year after it was invented? We want to do more things, and you started to see things like jQuery that allowed a lot of developers to create finally very dynamic website where you could do some async loading. For the ones who've been in the developing world for some years, might have heard of Ajax, which was asynchronous JavaScript and XML. Basically, you were able to load something from the backend and dynamically update your DOM. And for those who have written this kind of application, it was basically spaghetti. Mom spaghetti? No. Actually, spaghetti code. So it was the best day, it was the worst day. For those who have seen that code, it was really messy, but at the same time, it was magic. You didn't have to reload your page. You could have something that was dynamic. It felt somehow magical, I would say. And the year came after, around 2005, 2010, we started to see JavaScript not only on the front end, so not only in Navigator, you also had it in the backend. So someone had the idea, yeah, we have a new language. It would be good if the same stack could be used, the language stack, for the front end, for the back end. Let's create something that's called Node.js. Back then, it was kind of bad. Today, it's been much better. It's been, 20 years that it already exists. So, JavaScript everywhere. You might have seen a lot of technologies back then. Everything was in JavaScript. Your framework like Knockout, Ember, AngularJS, Backbone.js, it was JavaScript. With Cordova, you could have mobile applications that were also JavaScript. Your tooling was also JavaScript. For those who remember things like Power, that was your dependency management. On top of NPM, you had things like Grant, you could write your build script with. Everything was JavaScript. So, like I said, it's all JavaScript. And it's all JavaScript everywhere, actually. I took a Czech train from Vienna, and it went to undefined. I was happy to see that. I was like, okay, that's my word, that's JavaScript. Actually, there's a picture, you could see that even cars are actually using JavaScript and Angular, for example, in some of the UIs you see. I think that's one is BMW, and it's a bit pixelized, but it's RxJS. I don't see there's so many different versions. So yeah, JavaScript is actually everywhere. It's all JavaScript everywhere. By the way, JavaScript's awesome. Do you have an idea what happens when you try to sort an array with only numbers? Have you tried this?
Isn't it casting to string?
Exactly. Yes. It does, transforms that, and it does a sorting not by numbers, but alphabetically. Yeah, it's magic, it's dumb, but at the same time, that's what makes JavaScript so awesome. It does everything for you. So, Fast forward a bit, JavaScript is everywhere, 2015. That's about the year that Angular, the new Angular, not AngularJS, was created. So we had back-end, front-end, JavaScript everywhere. Everyone was quite happy, I would say. But there was one major issue. There was JavaScript on the left, and there was JavaScript, the good part. And it's awesome, but also not the best. So, again, another example. What makes JavaScript so awesome is that you can do really everything. Do you have an idea what this code does? B plus A plus plus A, something like this. What happens?
Banana.
It's banana! Of course, it's logical.
Well.
JavaScript's awesome, I told you. So what happened is that we had JavaScript, was like, we need to improve on that. So a lot of people had ideas, like some people had something built that compiled to JavaScript called CoffeeScript. People at Facebook, now called Meta, try a new language that compiled also to JavaScript called Flow. Google went another direction, said, okay, we need to start from scratch. We have a new language, which is Dart, which we can also compile to JavaScript. So we try new things. And, well, do any of you use them, one of those technologies for web today? For web, yes. Dart is used on Flutter today, but not to do web. So, yeah, they're all dead. So, it becomes interesting when this guy is like, you love code, he loves compilers. Like, he wrote Turbo Pascal, a few days later, Delphi, created also C#. So Anders, I don't know how to pronounce it. I don't know if we have some Swedish people who could pronounce that. Heisberg? Thank you. So that guy is my guy. He like, yeah, I have an idea. An idea is TypeScript. He's like, I created 3 languages. I created a 4th one on top of this. And TypeScript is basically not a new language. It is something that was built on top of JavaScript. So it was still JavaScript, but a little bit different on top. Because one of the issues we have is this very famous XKCD meme is that whenever someone tries to create a new standard to be better than all the previous standards, you end up with an additional standard. So from 14, end up with 15 standards. And that's a mess. We've been there. That doesn't work when you want to create something from scratch. So the idea with TypeScript was like, okay, we take the existing one, just make it better on top. It's still the same code that runs in the end. And for those who know, what's his name, Tom Scott, it's like, it's not the best language in the world, but it's actually one of the easiest ones. And this is one of the reasons JavaScript is so awesome, is that it's everywhere and it was easy to learn for a lot of people. It brought, one of the first line of code I wrote was also JavaScript. So it's like so easy, just open your browser console, you can start writing code and just execute. You don't have to learn about compilation and everything. It was simple, that's why it's ubiquitous today. Oh, JavaScript's awesome. Do you have an idea? Oh, shoot, I don't have the transitions. You can see that, for example, data API is one of the most magical ones. You try to do new date of 0, you end up with the base date of Unix on January 1st, 1970. You give it a string, starts in 2000. No logic. You give it a 1, okay, it's January 1st at 1 o'clock on 1970. You give it the same string. Oh no, it's not even 1 hour, 1 o'clock. It's different. You see, I mean, no logic. If you want to have a lot of fun and you will notice that you know actually nothing about the data API, I advise you to go to the link I give here, gsdet.wtf, gsdet.whatthefuck, and you have a lot of, it's a quiz that will test your knowledge about that API. And I scored very bad on this. It's like, makes no sense. But still, JavaScript's awesome. Like I said, it makes no sense. But let's go to a bit more toward what interests us today as Angular. Where does JavaScript fit in Angular itself? Well, Angular, if you look at the code base, the code is open source, you can see everything. So the compiler we have is written in TypeScript. So TypeScript, that is basically JavaScript. The CLI also fully written in TypeScript. So we have only JavaScript everywhere for Angular. Everything is built with something that could run in the browser. For example, you might not know, but the HTML you write is compiled to JavaScript. So whenever you write something that looks HTML, actually during compilation, Angular compiler will transform that into JavaScript. So your HTML is also JavaScript. It's all JavaScript, like I said. Here you have what we call instructions or IV instructions, which match basically the DOM. You can see that whenever you create a div, you have an instruction that say, okay, a new div starts, you have a new span, you have the text basically is here, and the end of the elements. This is the non-minified code, so whenever it's compiled, it's way smaller than this. But basically, whenever you create components, it runs first all the functions here, and when you have changed action that runs, it's only that part here, so that only the update. You can see that's here for optimization reason. I will actually only update that little part here in the DOM, which makes Angular so performant in terms of managing DOM. So in terms of performance, one of the things that is really important is that you reach as little as possible to DOM APIs. Creating nodes, deleting nodes is what will kill your performance. This is why, for example, I recommend that you use tracking functions, so you reduce the operation that's done on the DOM whenever you have lists where the elements change when you, for example, iterate on a table and want to switch pages. So one part here is that your HTML is actually JavaScript. Just to show you a little demo, I wrote a tool about 2 years ago. There's a QR code, I will give it after to you. It's published on my GitHub pages, and you can actually try what happens whenever you choose to write any HTML code. And here on the right, you have basically the code that's generated by the compiler. You can see the different instructions, how it looks like, and I give you some of the examples. You can see how it looks like when you have an NG4, an NG4 or a for loop. You will see that difference it's a little different, and also the fact that we went with something that is native to the compiler allowed us to optimize even more the performance around this. So a small tool. I need to go back here. Yeah. And if you want, the QR code will lead you to the web page. So this is for the templates, for example. But it's also something that is fully TypeScript, is that whenever you have your templates, I don't know if you remember almost 10 years ago, when you started Angular 2, you didn't have type checking on the templates. It just broke only at runtime. So a few years later, we added something that's called the TCB, the template type check, which allowed to have type checking in the template. And how do you do type checking with something that looks like HTML? Well, basically, it's also TypeScript, so it's also JavaScript. Here on the left, I have a template of a component, and here on the right, it's basically the code that's generated by the Angular compiler that is fed to the TypeScript runtime, and just tell us, okay, tell us here whenever something doesn't make sense in TypeScript words. So, is there something in terms of type that doesn't make sense? Should I report an error? And as you can see, there's a few numbers listed here. They are the position that match the template, so it could report exactly which part of the template was actually wrong. So from HTML, we actually also generate JavaScript, so TypeScript here, to do the type checking. And you could do that yourself. Imagine any Angular project, if you have in VS Code installed your favorite language service, which is the Angular language service here, you just go to the template, and you open the command palette, and you say, I want to see the template type check block. So here, I say, okay, I want to show this. It will display for you the type check block. So the JavaScript is generated to match the HTML that's on the left. So your HTML at runtime is JavaScript, at compile time, it's TypeScript, it's JavaScript everywhere. So JavaScript's awesome. I'm sorry because I used AI for that magnificent screen because I'm a lazy boy. But there is a problem. So JavaScript is inherently limited. Despite the JET compiler inside of, not Angular, but inside of the JavaScript VM, we have a JET compiler which optimizes it, but it's still a language that is interpreted. It is single-threaded. There are some cases where the runtime actually de-optimized the code, so it makes it way slower than it should. And there are some limitations, like for example, the numbers. Have you ever tried to do comparison with integers and and floating point numbers. They're basically all the same. So all the numbers you have in JavaScript, they're actually floating point numbers. So it gives you some limitations, make them also slower, etc., etc. So JavaScript is limited. And there was one realization amongst the JavaScript community is that JavaScript build tools are somehow CPU-bound programs. And we know that JavaScript is not a good language, or it's VM, it's not good for CPM-bound programs. So we need to think ahead and go say, okay, we have all our tooling in JavaScript. We need to shift. And this is what happened a few years back. You started to see a lot of tools that went the native route. For example, ESBuild is a bundler, was written in Go. You have RSPack that was also a bundler replacing Webpack that was written in Rust. Rolldown, TurboPack, also all written in Rust. So they noticed that you had much better performances by going with native tools to work with JavaScript code. But also, the whole tool chain moved, not only the bundlers. So you have SWC, which is a TypeScript compiler that doesn't do type checking, but is way faster than TSC. You have Biome, which is a tool chain program that does formatting, that does linting, etc. And you got the Oxy from the Void Zero team, which is a compiler, but does so much more, like also formatting and linting, also written in Rust. So there is a general moving away from JavaScript for the tooling, but still keeping JavaScript as such a language as is ubiquitous today. And we want to have better performance and better DX when we work with that language. Funnily enough, if you looked at the right GitHub profile, you could see this. There's someone here that was fairly active, had basically no contribution between August and October. And that guy was nothing else than Anders Helsberg. He was working, so I chatted a bit with the TypeScript team. It's like, yeah, basically Anders was working from his laptop for 3 months, wrote a prototype of TypeScript Go from his laptop without any versionings or anything. So if his laptop went down, he would have lost 3 months of work. Luckily for us, it didn't happen. And in March 2025, so last year, but a year ago, so they announced like, yeah, TypeScript is going 10 times faster. In the world of compilation, that's almost unseen. So 5%, 10%, that's already seen as great improvements for compiler. But 10 times, that's unseen. And that's basically because they rewrote, they're still rewriting today, 1.5 years later, the new TS in Go. 10 times the faster. The way they explain it is like 5 times is due to move from JavaScript to a native language, so you don't have all the limitation from the native from JavaScript. And the other 5 times is actually because you have a language that actually parallels work. So you have 5 times by going native and 5 times by being able to parallelize the compilation process. So we are all going native today. And the question I've heard a lot in the last 6 months, I've heard a lot in the last 6 months, is what does it mean for Angular itself? One of the pain points we have in enterprise projects today is that building and serving in dev mode your applications can take a lot of time. One of the last projects I've worked on was still using Webpack, but the dev server took more than 5 minutes to start. I'm talking web server, the dev server, it was painfully slow. How would we go the native way? So we already have ESBuild since V17, I believe, which improved about 2 or 3 times the build times for Angular apps compared to Webpack. But if we want to go TS Go, what does it mean? I didn't tell it yet, but the Angular compiler is a TypeScript program. It doesn't use TSC directly. It uses directly TypeScript as TypeScript code. By reaching deep into the TypeScript compiler API, it does the analyzes, it parsing all the code, like all the templates, it does the optimization, everything. So it's a huge TypeScript program that takes HTML, TypeScript, transform it, and at the end generates JavaScript. This won't be possible with TSGO because TSGO, they change a bit the strategy. So, okay, we want to limit the set of API that's accessible for the people to use. And it means that cases where Angular is actually reaching for it, it's not possible. It won't be possible anymore in the future if we want to use TSGO. So the solution is to actually finally rewrite the compiler. So the solution, I wouldn't say the solution exists yet. We are still working on some prototypes, looking at what we can do, how we can improve. One of the solutions is to actually use what the Voice0 guys and girls have been working on with the Oxy compiler and Oxy stack. One of the ideas would be that we split the compilation into two phases, like you have a preprocessor that takes everything that's Angular related, compiles it to TypeScript, and then we can give it to any TypeScript compiler, for example, TSC, but in the future, for example, TSGO. So by rewriting it, we make ourselves more tooling agnostic by not reaching directly into TypeScript API, but you will just depend on whatever other technology are already using today, like other frameworks. Some of you might have seen that also the Voice0 guys have written an experimental Angular compiler with impressive numbers. Like they give one benchmark, but they announce like 20 times the improvement in compilation speed. Those are great numbers. It at least sets expectations, but one of the things might not be visible to everyone is that it doesn't do all the work the Angular compiler does today. It's not work that I think that we can rely on directly. It's an interesting project. It lacks, at least in two ways, it lacks some optimizations, and also it lacks type checking into the templates, which is things that you would want to have. So interesting in terms of numbers, but for production is not something that you will use. So in the end, we are in a year where things will move around the topic of compiling apps, building apps to reach new performance, to be able to adopt the new tooling that is moving toward native languages. So it's quite possible that during this year you will see an Angular compiler at least partly written in Rust. So I was talking about JavaScript. JavaScript's awesome. So have you ever heard of GS, I think it's called GSFAQ? Yeah, exactly. I wrote some little code here in GSFAQ. Just to show you, it's basically plus bangs, exclamation mark, plus brackets and braces, exactly. Just to show you, I won't lie. I'm copying the code. Do you have an idea what that code does?
Prints out Angular.
Are you ready? Exactly. So yeah, JavaScript's awesome. It's not perfect. It's going in a direction that's fascinating, I want to say. It moves a lot. We're probably behind the day we could say the joke here every month or every day there's a new JavaScript framework. You see that somehow the tools stabilize toward one single direction. Going native for all the tooling is very interesting in terms of the numbers we already see. So yeah, I'm excited to see what 2026 will bring us for JavaScript. Thank you very much. You will find my talks a bit later on my webpage. And if you want, I can answer some questions further about the talk and then about anything about Angular if you want to. Thank you very much. And Michael's not here.
I left the honor. Want to go first?
It's just another example of a very funny JavaScript thing is you say parse int,
Yes.
and you say 0.005, what would you expect?
Depends on the second parameter or the third one.
Without that.
I don't remember what it does.
No, I think it's very funny. It's casting the 0.005 to string, and then it checks one by one if it's a number or not. But there is an error there because 0 essentially will give you like false too, so it thinks it's such a number. So parsing 0.005 is going to be 5.
Excellent. I love JavaScript. JavaScript awesome, like I told you. Other questions? Yes.
Yo. I don't know if I would like you to maybe talk about the future. You're talking about that there are Angular compilers coming. Recently, I've been working or starting to work finally with the signals and getting used to it and so on. And something that I was shocked to see that the resource was still experimental. Is it not going to be experimental in 22 in May?
That's one of the goals we have. So I can't say yes, it will be stable in 22. I can say that yes, we would want it to be stable. There are a couple of PRs that are pending, so a lot of work is actually happening on resource to make sure that we're close to be convinced that it's what it should work, how it should work. I don't know if Rainer is here. Rainer has some strong arguments on the resource. I mean, it's interesting, always passionate discussions, but we'll see how it's going to happen. But that's one of the goals we have.
And any other sneak peek or like what are you more excited about this new?
I mean, who hasn't tried the signal forms yet? I mean, I'm going to say you should. I gave a talk presenting signal forms a couple of months ago in Paris, just at the Paris meetup. And one of the guys told me, say, really, it's tough to have seen the signal forms and going back tomorrow writing reactive forms. And in terms of API design, I love the work that the team that's been working on this has done. And it's really feels like you are working with the framework and not against the framework anymore by writing forms. And I guess that everyone who writes Angular apps ends up writing forms because that's what we mostly do. So having finally an API that's easier to use, where you got better composition, type checking, and it's just better DX, better performance, less edge cases, weird edge cases. It's going to be a huge relief to anyone working with forms.
But it will be developer preview or still experimental?
That depends on how well it goes. Right now, we're quite optimistic because people like it a lot. Feedback we get inside Google, but also outside Google are very good. There's still a lot of cases we want to think about, but it could be maybe stable or developer preview. Right now, it's still experimental, which allows us to just iterate very fast on it without being stopped by just release versions. So we're still 2.5 months ahead of V22, which is expected for the end of May. So there's still a lot of work to happen, and I hope that we can get something that is not experimental. But we'll see.
Nice. Thank you.
Thank you. Do we have more questions?
No?
Yes. Rainer also wanted a question. Yes.
Yeah, in terms of signal forms API implementation, is it all just JavaScript?
It's TypeScript. Got it.
I didn't get the reason why why Rust is not Go, especially.
You're talking about the TS implementation?
No, yours, because you said you want to write the compiler code in Rust.
So because there's one tool that's really interesting, it's what the Void Zero guys have been doing, it's Oxy. So it's a huge site which gives you the parser and a lot of things, which is very interesting. And also because our lead loves Rust, so why not?
There is not really a reason why you would say this is why it doesn't work with Go.
I don't think there's a real reason. Like, for example, Microsoft. went with not in-home technology, they went with Google ones like Go. I don't know if you know why actually they went with Go, because there was a huge meltdown on the internet in March 2025 of last year. So why did you went with Go? You had the Rust guys and girls that are like, yeah, Rust is more performance, better memory management, etc. Why didn't you go with Rust? And you got the .NET guys who was like, hey, Microsoft doesn't believe anymore in C#, like it's not performance, why should we use it then? There were very reasonable reasons, and the TypeScript team went into extensive explanation onto why. I can give you two major reasons. First, there is no TypeScript spec. The only spec that exists is the unit test and the existing code base. So when you want to start from scratch without a spec, you can make sure that you will mess things up. And they wanted to have something that is close to TypeScript or JavaScript in terms of how the language behaves. And Go basically was that. So it's a language that is garbage collected, like TypeScript, JavaScript, and also it was a language that was massively parallel. So you could parallelize easily with Go. You could have something that could be migrated automatically, at least part of it, from TypeScript to Go. And that's basically one of the reasons why they choose Go for it. Like maybe with Rust they could have gotten 15 times the performance, but going 10 times with something that could be automated, and maybe in less than 2 years, that would be unseen, and that would be such a huge achievement. And the numbers they've announced a year ago are still very valid today. They update the benchmarks, people give a lot of feedback also. Yeah, the numbers are here. It's around 10 times faster. It's very impressive.
So you're not afraid, I mean, because then in case you're doing your rewrite in Rust, that it's then really decoupled? Because it would be very hard, maybe if you...
It's actually a valid concern, saying, okay, we are a team that's expert with TypeScript, and we start going with another language. And Rust isn't known as being a very friendly language because it's low level, etc. But we are at a time where we all have access to experts. When I say experts, I'm talking about the LLMs. So basically, if you don't understand anything, you just ask the LLM. It could explain you probably 9 out of 10 cases. So with your at least with our expertise in the team, plus the knowledge we can gain quite quickly by having access to experts, the LLMs, but also other experts outside, it's less of a problem to bring a new language. It's really like the opportunity is here to say, okay, we need to rewrite the compiler because we want to be able to address a TS-Go in the future whenever it's stable. But we need to rewrite it, and going native, as we've seen with what Void Zero showed, we will gain performance, at least on our side of the compiler, but also by using TS-Go at the other end.
Okay.
Awesome. Do we have any more questions?
Yeah. So before it was mentioned,
The microphone.
before the first talk was mentioned that services that are provided in even in other components or modules in the past and so on, they are not destroyed. That it's a bit against what initially you might expect on something. Is this by design? Is this something that you currently cannot do, or why is this memory kept there, or is it not marked for garbage collect or whatever, or I don't know.
So to answer quickly to your question, it's basically by design. But it's also by design means that we can also evolve the design. And one of the issues that has a lot of feedback was recently that, the issue has been open for 5 or 6 years, I think. It was destroying providers that were provided on routes. When I say routes, not the root provider, but on different routes. And in 21.1, so the one released in January, we added a feature which allowed you to destroy the providers that were defined on a specific route. So basically, we could finally destroy things so they're not in memory anymore. Since it would be a breaking change to have it by default to destroy them when you leave the route to destroy the instances, for example, your store. It's something that is opt-in, but you could destroy it. And for the topic of ng modules, I would consider them, at least myself, and I think it's the position of the whole team, is that today they are part of legacy code, and I would never write a new ng module today. And I could even say that new applications at Google are not allowed to have ng modules anymore. So at least new code doesn't bring in old patterns.
Thank you.
Any other question? Yes.
Just electrocuted. I was wondering, how do you go about breaking changes? What things are considered? Do you look at usage numbers of certain APIs? What data do you have? And how do you think about the others?
So basically, the first data source that we have is Google's monorepo. So you might not know, Google has a gigantic monorepo. It's about 4,000 Angular apps. So basically, I can try every day, I try a change, open a PR and check, hey, how breaking it is. For example, I just checked the numbers earlier. The change in V22, we intend to make on push the default change detection strategy. And that change entails about 100,000 files to change. It's massive. It's massive for you, imagine for us. So someone has been working on and off for about a month to migrate the whole code base with migration scripts, but it gives us an idea how big it is. So either it's something that is small, we can do it by hand. If we can do it by hand, you can do it by hand. If it's big, it needs to be something that is migratable, or there needs to be a large advantage to do that breaking change. And the breaking change only happens in major versions, so every 6 months we have a small 2 or 3 months window where we can check what is breaking, land the breaking change, and make sure that the transition isn't too painful for us and also for you.
More questions?
Behind?
Can you hand it back?
Yes.
I meant really back, not back to me. You get the 10th ticket number today. If you don't win something, then... So, that was a joke. You got it?
In the previous joke, the previous talk we spoke about agentic UI.
Yes.
And you mentioned that framework should probably provide something
Yes.
for agentic UI specifically.
I don't have the visibility of what everything is doing, everyone's doing. I know there's some people that want to work on how to, it's more about thinking how we would write interfaces in the future in a world where at least part of our interaction will be with the agents. So we won't be interacting with mouse and keyboard like we did until now. That interaction will still exist, but new ones will be added. And this needs a lot of work of thinking of how it will impact how we write our applications. And some people are actually working. I don't have the results now. It will take probably a bit of time to see where it leads. So the idea, I think, is to make it easy for developers to express that this part is actually from an agent and make sure also there is a minimal security risk. Because there's also always a problem of running code that you do not own. And if it's generated, even if the agent by itself is not malicious, sometimes there are some unfortunate issues. And I just read on Twitter like half an hour ago, there's a company that had an agent that had access to production and destroyed the whole database. So yeah, there are some risks. You might have heard what's the name again? OpenClaw, which people used in many cases. So it exposed some keys or, there are a huge security risk. It's great to have a prototype, proof of concept of ideas, but going into production today would say it's very risky. So there's a lot of work that needs to happen to make things that are at industry level, that's secure, and there is not too much risk to run into your code bases. It's a lot of topics, not only on the UI part, but also in the whole ecosystem, how we should interact with this kind of new interaction, I would say.
There is this project, I don't know if it's from Google, A2UI.
Yes, I've heard of it too. Actually, I think somehow, you might know Minko from, there was for a very long time a developer on the Angular team, also a product responsible for the whole product, who shifted more into AI, who is looking a lot into this. So you might, if you want to see a lot on that topic, I would advise you to still follow him, even if he talks less about Angular, but is very invested into the topic of AI, of course.
Thank you.
Welcome.
More questions? Maybe one more, small one. Sad question.
Thanks. Regarding how much are you actually using AI when developing in Angular, especially when it comes now to a new compiler? It's a lot of effort and it's very competing to just use AI.
So I will answer this in two ways. There is not a day where I don't use AI, for example. Sometimes the small auto-completion, that's what I call top-driven development, TDD. So you write just the assertion of your code, say okay, and it generates often the right unit test. I'm like, super, I love that. Sometimes you say, okay, I'm a bit lazy, I give you some specs, I give you some failing tests, fix that issue for me. That's a good way to just implement things. Today, AI makes it basically the code not an issue anymore. It makes us so much faster in terms of development or time of writing the code. I flew into Vienna on Monday. I coded a bit on the plane, and I felt some kind of frustration because short-haul flight, there was no Wi-Fi, no smart autocomplete. I was working on unit tests, like, I'm feeling so slow. So there's kind of some frustration when you don't have it. At least that's what I felt. So AI is totally into our workflow. There's also an interesting point is that whenever we develop new APIs, so 21.2, we added something that is called, or also in 21.1, around the switch cases where we want to see fall-through cases and also what we call exhaustive type checking. Since AI is going to interact much more with the code, with the APIs, we need to make sure that AI understands code it hasn't seen. So if you gave the AI some examples, say, okay, that's how it works, can you generate it? Yes or no? If it doesn't, you need to change a bit of the API so the AI understands it. Because we noticed that when analyzing how AI behave, the team actually released a tool which is called Web Code Gen Scorer, which help us understand how different AI work and how which variable improved the output. We noticed that AI actually makes usually the same mistakes as developer. So if we target APIs to work well with AI, we kind of make sure that it's easier for the developer also to learn. If the AI has some pitfalls with the API, it means that developer surely will also have. And it gives us feedback way quicker than waiting 6 months for developer feedback. So somehow it makes us also faster in iterations in understanding what works and what not. So in multiple ways, AI is improving a lot our velocity, I would say. But also, like, it kills a lot of velocity because we need to work a lot on AI too. So it's like with balance.
Was it the last question? If yes, and I assume that's a yes, we...
Thank you very much for the question. Thank you too.